Hi everyone, this is Professor Oaks, and in this video we are going to discuss area and arc length in polar coordinates. So let's start out by talking about the area of a region in polar coordinates. So consider the curve whose polar coordinates is r equals f of theta, where f is a continuous function, and as theta increases from theta equals alpha to theta equals beta, the point P equals f of theta theta moves along the polar curve from f of alpha alpha to f of beta beta, and the radial line segment O to P, or from the pole over to the point P, sweeps out a plane region. And we refer to this region as the region enclosed by the polar curve between theta equals alpha and theta equals beta. Now, the formula for the area of this region is A for area is going to be a 1/2 integral from alpha to beta of r squared d theta. So try to remember this formula for the rest of your life. Now, let's do an example of applying this formula. Find the area enclosed by the polar curve r equals 2 secant squared theta between theta equals 0 and theta equals pi over 3, and sketch the curve. So let's look at this. So alpha is 0, beta is pi over 3. So if we want this area, we have 1/2 integral from 0 to pi over 3, and then we have r squared, so that will be 2 secant squared theta squared d theta. Now, let's go ahead and square this here. So we have 1/2 integral from 0 to pi over 3 of 4 secant to the 4th power theta d theta, and then move the 4 out in front, so 4 times 1/2 is 2, so 2 times the integral from 0 to pi over 3 of secant to the 4th power theta d theta. Now this is a simple integral using the powers of the secant here. So we have 2 integral from 0 to pi over 3 secant squared theta times secant squared theta d theta. Now, let's change one of the secant squared thetas to, let's use this one, tangent squared theta plus 1. Now, we'll distribute the secant squared theta here. So we have 2 integral from 0 to pi over 3 of secant squared theta tangent squared theta plus secant squared theta d theta. And now, let's go ahead and, you know what, I don't know if we'll have enough room, so I'm going to bring up the next page here that I have. So let's see, we have 2, and let's split this into 2 integrals. So 0 to pi over 3 of secant squared theta tangent squared theta plus d theta plus 2 integral from 0 to pi over 3 of secant squared theta d theta. Now, the integral on the right here is the easier one to do because this is just the tangent of theta plus c. All right, now let's do this integral over here. All right, integral of secant squared theta tangent squared theta d theta. So, well, if you let u be the tangent of theta, then du is secant squared theta d theta. So this integral becomes the integral of u squared du. So that will be 1/3 u to the third plus c or u was tangent of theta. So 1/3 tangent to the third theta plus c. Now let's go back to our definite integrals up here. So we have 2 times a third tangent to a third theta plus 2 tangent of theta, all evaluated from 0 to pi over 3. All right, so let's see what we have here. We have 2/3 then times the tangent of pi over 3 to the third plus 2 tangent of pi over 3, then minus 2/3 tangent of 0 to the third minus 2 tangent of 0, and the tangent of, let's see, pi over 3 is the square root of 3. So we have 2/3 square root of 3 to the third plus 2 tangent of the square root of 3, then minus 2/3 tangent of 0 is 0. Oh, sorry, I didn't mean to write tangent here again. I just realized I wrote tangent again. So tangent of pi over 3 is square root of 3, and then let's see, minus 2 tangent of 0 is 0. So this entire part here is 0. So the square root of 3 to the third actually is 3 square root of 3. So we have 2/3 times 3 square root of 3 plus 2 square root of 3. These 3's divide out. So we have 2 square root of 3 plus 2 square root of 3 is 4 square root of 3 units squared. Remember, this is the area, so it's in square units. All right, so now hopefully that all is just a review of some simple integration for you. And now let's sketch the curve. So we want to sketch r equals 2 secant squared theta between the theta equals 0 and theta equals pi over 3. All right, so let's do this. Let's just make a table here. Theta and r equals 2 secant squared theta, or 2 over the cosine squared theta. All right, so here is the polar axis. Here is the pole. Now, we want, if theta is 0, we get 2 over the cosine squared of 0 is 2. So 1, 2. If we pick some other numbers in between 0 and pi over 3, say, let's go with 15 degrees or pi over 12, 30 degrees and pi over 6, or 45 degrees, which is pi over 4, and 60 degrees, pi over 3. That should give us enough idea of what this looks like to go about our business here. All right. So at 45 degrees, well, let's go one at a time. All right. At 15 degrees or pi over 12, I'll let you use your calculator, but I get 2.1436. And for pi over 6, 2.667. I'm rounding because I can't draw this very accurately by hand regardless. And at pi over 4, we get 4, and at pi over 3, we get 8. So let's do the ones with the whole numbers first. So at pi over 4, we get 4. So 1, 2, 3, 4. So this is one of the points. Now at pi over 3, we get 8. So 1, 2, 3, 4, 5, 6, 7, 8. And at, let's see, pi over 6, we get about 2.7. So pi over 6, let's see, 1, 2, and then a little bit like 2.67. Right? And then at pi over 12, 2.14. So 1, 2, and then a little bit past that. And then we see that at 2, on the on the polar axis, we have a point. So this actually, if I draw it with any accuracy at all, will look like this. All right, so there you go. That is a sketch of this curve. So hopefully you enjoyed that sketch here. So let's do another example here. So in using the formula, A is 1/2 integral from alpha to beta of r squared d theta to find the area of the region enclosed by a polar curve, r equals f of theta between theta equals alpha and theta equals beta. You must be certain that alpha is less than or equal to beta and that the radial line segment from the pole to P, where P equals f of theta, theta sweeps out just once across each point in the interior of the region. All right, so if it doesn't, then you'll be double counting the region, and that would be really bad. All right, so find the area enclosed by the polar curve. R equals 3 cosine of theta plus 4 sine of theta. Sketch the curve and determine the appropriate limits of integration. Make certain that none of the area is being counted twice, which I just warned you against. Okay, so let's make a table. Theta and r equals 3 cosine of theta plus 4 sine of theta. So let's start at 0 because that's usually easier. And, well, what would we have here? Well, let's go with the 3 cosine of 0 plus 4 sine of 0, which is 3. So let's graph that point here. This is the polar axis. And when theta is equal to 0, we get 3, 1, 2, 3. Now, let's try, say, pi over 4. And I'll let you use your calculator, but this is 4.9497, about 4.9497. So at pi over 4, we get something around 5. So 1, 2, 3, 4, a little under 5. All right, so this is the pi over 4. So 4.9497 pi over 4. Remember, these points are of the form r theta. All right, at pi over 2, we get 4. So 1, 2, 3, 4. So this is the point of 4 pi over 2. And at, let's say, 3 pi over 4, I get 0.7071. So at 3 pi over 4, I get something a little under 1. So this is 0.7071, 3 pi over 4. Then let's try pi. At pi, I get -3. So if you think about that, though, think about this. If I have at pi, all right, 1, 2, 3. This is pi, but I want r to be -3. So this point, -3 pi, and 3, 0 are equivalent points. So let's try another point like 5 pi over 4. I get about negative 4.95 approximately. So these are the same point also. Right, these two end up being the same. These two end up being the same. So then at, let's say, oh boy, oh, I drew the, I did draw the arrows pointing to weird spots, but I think that you get the idea here. So I just realized that arrow pointed to a really weird spot. Now, let's try, say, 3 pi over 2. That will give us negative 4. 7 pi over 4, negative 0.707. 1 and 2 pi will be 3. So if you noticed, then this is at pi is where the points started repeating themselves. All right, so that means that the graph looks something like, and I'll make my best guess at a sketch. All right, so like I'm not the best graphic artist, but I think that you get the point here, that it looks something like this. All right, so the area then will be 1/2 integral from alpha to beta of r squared d theta, but we just realized that these start repeating at pi, so I'm going to have 1/2 integral from 0 to pi of r was 3 cosine of theta plus 4 sine of theta, so r squared d theta. Now I'll multiply this out. So 3 cosine of theta plus 4 sine of theta times 3 cosine of theta plus 4 sine of theta. And I get 1/2 integral from 0 to pi. What do I get? 9 cosine squared theta plus 12 sine theta cosine theta plus 12 sine theta cosine theta plus 16 sine squared theta d theta. I'll combine the like terms, so I have 1/2 integral from 0 to pi of 9 cosine squared theta plus 24 sine theta cosine theta plus 16 sine squared theta d theta. Now we need to use the trig identities to figure this out here. So we have 1/2 integral from 0 to pi, and I'll rewrite cosine squared theta as 1/2 times 1 plus cosine of 2 theta. Then I'll write sine theta cosine theta as 1/2 sine of 2 theta, and I'll rewrite the sine squared theta as 1/2 times 1 minus cosine of 2 theta. So we have that d theta. What a time to be alive, right? Now let's go ahead and we will distribute the 9/2, right? Distribute the 16 halves. So we have 1/2 integral from 0 to pi of 9/2 plus 9/2 cosine of 2 theta plus 24 times 1/2 is 12. 12 sine of 2 theta plus 16/2 is 8. So plus 8 minus 8 cosine of 2 theta d theta. Now I will combine the like terms here. Let me get another piece of paper here just so that I don't scrunch everything together and make it too hard for you to read here. because your comfort is my #1 priority. So this will be equal to 1/2, 0 to pi, 9/2 plus 8. That will be, what will that be? That will be 25/2. Then 9/2 cosine of 2 theta minus 8 cosine of 2 theta is minus 7/2 cosine of 2 theta. Then we still have the 12 sine of 2 theta here. Then d theta. Now, I really don't think it matters too much how you do this, but just make sure that you don't forget about this half out here no matter what. All right, so, well, I just distribute it in just to make sure. So 25/4 minus 7/4 cosine of 2 theta plus 6 sine of 2 theta d theta. Now, what I need to do then is go ahead and integrate. So the integral of the 25/4 with respect to theta is 25/4 theta minus 7/4. I need to let u be 2 theta here. So I'll need to have what do you need? You need a half sine of 2 theta plus 6. Same thing here. U is 2 theta times a half times negative cosine of 2 theta. Evaluate this from 0 to pi. So we're left with, let's see, 25/4 pi minus, this will be 7/8 sine of 2 pi. This will be minus 6/2 of 3. So 3 cosine of 2 pi minus 25/4 times 0 minus 7/8 sine of 0 minus 3 cosine of 0. So now we have, let's see, 25/4 pi sine of 2 pi is, well, 0. So this is equal to 0. So minus 3. Right, this is equal to 1. This is equal to 0, equal to 0, equal to 1. So minus the negative 3 times 1. So this will be, well, negative 3 minus negative 3 is 0. So 25/4 pi. What a time to be alive. So this is the area. So this is units squared. All right, I really hope that you enjoyed this example here, because now it is time for the area between two polar curves. So all the intersection points of P of the polar graphs of r equals f of theta and r equals g of theta can be found by carrying out the following procedure. 1. Check that each polar graph is separately passing through the pole O, and if both of them do, then O is an intersection point of the graphs. Then solve, if possible, the simultaneous equations. R equals f of theta and r equals g of theta plus 2n pi. And then for r, theta, and n, where n must be an integer, for each such solution, the point P equals r theta is an intersection point of the two graphs. And then solve, if possible, these two equations simultaneously. R is f of theta, and r is the opposite of g of theta plus 2n plus 1 pi. And then for r, theta, and n, where r is not equal to 0, and n must be an integer, for each such solution, the point P equals r theta is an intersection point of the two graphs. So now, suppose we wish to find the area A of the region enclosed by the graphs of the two-polar equation between the 2 points of intersection. P1 is R1 alpha and P2 is R2 beta. Then the area is the 1/2 integral from alpha to beta of f of theta squared d theta minus 1/2 integral from alpha to beta of g of theta squared d theta, and this will be 1/2 integral from alpha to beta of f of theta squared minus g of theta squared, and we need another parentheses, d theta. So try to remember this for the rest of your life, please. All right, so let's do an example here of finding all intersection points inside of R equals 6 cosine of theta and outside of R equals 6 times 1 minus cosine of theta. So let's go through the steps one by one. So step 1 was do the graphs pass through the pole. Well, you can set R equals 0 to find out. All right, so let's do that today. So for the first equation, we had R is 6 cosine of theta. So 0 is 6 cosine of theta. So if I divide by 6, I get 0 is cosine of theta. And I know that then theta would be pi over 2. So what this means is R theta equals 0 pi over 2 is on R equals 6 cosine of theta. Now, I know that R equals 6 times 1 minus cosine of theta. So 0 is 6 times 1 minus cosine of theta. I'll divide by 6 to get 0 is 1 minus cosine of theta. Then I'll add cosine of theta. So cosine of theta is equal to 1, and theta would be 0. So, well, what I know then is that R theta equals 0, 0 is on R equals 6 times 1 minus cosine of theta. So what does this mean then? It means that therefore the graphs pass through the pole, and the pole O is a point of intersection. All right, so we found one point of intersection already. All right, step 2. And I'll follow the steps right as I stated them. So step 2, here I'll rewrite that for you. All right, so I expect you to remember all these, but I'll write it up here again. So it's to solve this set of simultaneous equations. R equals f of theta, and R is g of theta plus 2n pi. So in this case, that will give us R is 6 cosine of theta, or R is 6 times 1 minus cosine of theta plus 2n pi. All right, so now we'll see if they intersect. So we'll set these equal to each other. 6 cosine of theta equals 6 times 1 minus cosine of pi times 2n plus theta, or theta plus 2n pi. I'll divide by 6 to get cosine of theta is 1 minus cosine of theta plus 2n pi. Now, you need to remember this identity here. Cosine of theta plus 2n pi is cosine of theta. So try to remember again every trigonometric identity that you've ever learned in your entire life. So cosine of theta equals 1 minus cosine of theta. So I'll add the cosine of theta to get 2 cosine of theta equals 1. Divide by 2. Cosine of theta is a half. So then I know that cosine of theta is a half when theta is pi over 3 or the opposite of pi over 3. All right, so now what that tells me is that 3 pi over 3 and 3, the opposite of pi over 3, are points of intersection. And as a reminder, how did I get what r was? Well, r was 6 cosine of theta, right? So that will be 6 cosine of pi over 3, and that will be 6 times a half, which is 3. All right, what a time to be alive. Now, we've only done steps 1 and step 2, so let's move on to step 3 here. So step 3 is going to be, all right, hopefully you remember the steps by now, but it is to solve this set of equations here, and that will be r is f of theta, and r is the opposite of g of theta plus 2n plus 1 pi. So that will give us, in this case, r is 6 cosine of theta, or r is the opposite of 6, 1 minus cosine of theta plus 2n plus 1 pi. All right, so hopefully that is okay with you, and we'll solve these by setting the two r's equal to each other. So 6 cosine of theta is the opposite of 6 times 1 minus cosine of theta plus 2n plus 1 pi. That's enough parentheses. All right, so now I'll divide by 6. So cosine of theta is the opposite of 1 minus cosine of theta plus 2n plus 1 pi. Then I know that cosine of theta plus 2n plus 1 pi is just going to be cosine of theta using the same identity as before. Then I'll distribute this negative here. So cosine of theta equals the opposite of 1 plus cosine of theta. Subtract the cosine of theta, so we get 0 equal 1, but 0 does not equal 1, so that means therefore there are no more points of intersection. All right, so what a time to be alive. All right, so now let's go ahead and graph this here. All right, graph. So r equals 6 cosine of theta, and r is 6 times 1 minus cosine of theta. So let's see, I'll draw the axes right here. I'll try to draw it as nicely as possible for you. I can't guarantee anything here, though. All right, so we knew that one of the intersection points was, if you remembered, right, 0, 0. And then we knew one of them was 3 pi over 3. So let's say pi over 3 is over here. So 1, 2, 3. So here is one of the intersection points, and that 3 pi over 3. And then another one will be 3 and negative pi over 3. So negative 1, negative pi over 3. I was drawing another point here. So negative pi over 3 So, yes, where is it? So 3 negative pi over 3, so negative 1, negative 2, negative 3. Okay, so here is the point, and that will be the 3 negative pi over 3. All right, so now let's graph these. So let's do theta and then r. So 0, 6 cosine of 0 is 6. Pi over 3, I already knew was 3. 2 pi over 3 will be a negative 3. So 2 pi over 3, negative 3 will give us this point over here. Then pi, negative 6. So at pi, you get negative 6. So that means that there's actually a point at if we go 1, 2, 3, 4, 5, 6 at pi, but you go negative 6, it's actually over here. 1, 2, 3, 4, 5, 6. So this is negative 6 pi. And then we get pi over 2, 0. So that is actually the point right here. This is actually 0 pi over 2 right here. All right, so this function, hopefully you can see the points connecting, but it looks something like an awkward egg sort of shape, or an almond or something like that. All right. Now, for the other graph, theta and then r, we get 0, 0 right here. Pi over 3, 3 we know is a point already. So 2 pi over 3, 9. So here is 2 pi over 3, and we need 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then let's do. Well, it's too late now. So pi 12. All right, so at pi we have 12, so 6, 7, 8, 9, 10, 11, 12. So this is 12 pi, and this is, what was that? That was 9 and 2 pi over 3. And then let's do 5 pi over 3. That will give us a 3. And so 5 pi over 3, 3. And then, let's see, one more. How about 2 pi and 0? All right, so that brings us back to where we started here. And then how about 4 pi over 3 and 9? All right, so 4 pi over 3 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This point will be 9, 4 pi over 3. And then again, this point over here is also the 5 pi over 3, 3, so 3 and 5 pi over 3. All right, so now let's graph this. So it doesn't, we start at 0, 0, and then we'll say that we go over to this point, and then over here, and then over here, and then back, and then we'll loop back in like this. All right, so this curve I'm going to highlight in yellow so that you can see it a little bit better. There we go. So now you can definitely see the intersection of these curves is right here and right here. Right? So if you want to find this area, then you can find the area of just one of these parts and then double this. So let's find the area. So the area is, remember, it would be, where is the formula? I want to show you the formula again in case you happen to forget it already. Here it is. All right. So it is 1/2 integral from alpha to beta of f of theta squared minus g of theta squared d theta. So try again to remember this for the rest of your life. And now we see that this is going from 0 to, let's see, or 0 to, because remember this is also 0, 0. All right. 0, 0. 0 to pi over 3. And we double this to get both of these areas at the same time. So 2 times 1/2, 0 to pi over 3. And the first curve was g 6 cosine of theta. And this other one was, what was it? It was 6 times 1 minus cosine of theta. So we have 6 cosine of theta squared minus 6 times 1 minus cosine of theta squared d theta. Now I'll multiply this all out here. So hopefully you're truly enjoying this. I really hope that you are. So this will be 2 times 1/2, 1. So we have integral from 0 to pi over 3. 6 times 6, 36. So 36 cosine squared theta minus 36 times, now this will be 1 minus cosine of theta times 1 minus cosine of theta. All right, so 36 times 1 minus 2 cosine squared theta plus, cosine of theta plus cosine squared theta, and then d theta. And let's distribute the negative 36 here. So we have the integral from 0 to pi over 3 of 36 cosine squared theta minus 36 plus 72 cosine of theta minus 36 cosine squared theta. All right. D theta. Now 36 squared cosine squared theta is 0 out. So we have integral from 0 to pi over 3 of negative 36 plus 72 cosine of theta d theta. Now we just find the integral. So this will be the negative 36 theta plus 72 sine of theta. Evaluate it from 0 to pi over 3. So now what do you have? You have, let's see, negative 36 times pi over 3 plus 72 sine of pi over 3 minus negative 36 times 0 plus 72 times sine of 0. So this is 0. So this whole part over here is 0. So we have, let's see, negative 36 times pi over 3 is negative 12 pi. And this will be plus 72 times, well, sine of pi over 3 is square root of 3 over 2. So Then we have 72 times square root of 3 over 2 is just 36 square root of 3. So that is the area of those parts of intersection of the two curves. All right, so try to remember this for the rest of your life. All right, so now one last topic here, and it's arc length in polar coordinates. So the arc length of a polar curve. So the arc length of the portion of a polar curve r equals f of theta between theta equals alpha and theta equals beta is given by s is equal to the integral from alpha to beta ds. So that's the integral from alpha to beta of the square root of dr d theta squared plus r squared d theta, which is the integral from alpha to beta of the square root of f prime of theta squared plus f of theta squared d theta. All right, I probably made these square roots a little bit too long, but that's okay. All right, so this is provided that the derivative f prime exists and is continuous on the interval from alpha to beta. And remember, this is a closed interval because we have not talked about any integrals where there might be a discontinuity at the endpoint, at least not yet. All right. So find the arc length of r equals -7 cosecant theta from theta equals pi over 4 to 3 pi over 4. So now we need dr d theta. So that will be, let's see, that will be the -7 times negative cosecant of theta, cotangent of theta. So if I multiply this together, I get 7 cosecant of theta, cotangent of theta. So this is my f prime of theta, and this I can just call my f of theta, all right? So now the arc length is s is the integral from alpha equals pi over 4 to beta is 3 pi over 4. Then we have the square root of f prime of theta squared, so 7 cosecant of theta, cotangent of theta squared plus, what do we have here? We have -7 cosecant of theta squared d theta. Now, let's simplify under the square root. So if I square this here, I get 49 cosecant squared theta, cotangent squared theta, plus 49 cosecant squared theta d theta. Now, I'll factor out the 49 cosecant squared theta. So I have 49 cosecant squared theta times cotangent squared theta plus 1 d theta. But now use your identities, and this will be cosecant squared theta. So I have the integral from pi over 4 to 3 pi over 4 of the square root of 49 cosecant squared theta times cosecant squared theta d theta. But if I multiply this together, I hope that you're finding this problem as exciting as I am, because it's 49 cosecant to the 4th power theta d theta. And if I take the square root here, I have the integral from pi over 4 to 3 pi over 4 of 7 cosecant squared theta d theta. And I can bring out the 7 and find the integral. So 7 times negative cotangent of theta, evaluate it from pi over 4 to 3 pi over 4. So -7 cotangent of 3 pi over 4 minus a -7 cotangent of pi over 4. And try to remember this here, but the cotangent of 3 pi over 4 is -1, so I have -7 times -1 plus 7 times the cotangent of pi over 4, which is 1, so 7 plus 7 is 14, so I have 14 units. And this is arc length, it's not the area, so this is not in square units, it's just 14 units is the length of this curve. Now, I hope that you enjoyed this video on the 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 area in arc length and polar coordinates, and that you have a great day. Thank you for watching, and I hope that you are already looking forward to the next video. What a time to be alive.